We're going to talk about supervisory strategies and behavior in Elixir. I've started off with a really simple application. It has three modules that basically send a message to themselves every second and increment their state by one. These will run because they're started by the application as children in the order of one periodically, one another, and one third. These three modules have slightly different behaviors. One of them will fail when it reaches a state of 22. The other will fail when it reaches a state of 5, and the third one never fails. By leveraging and some inspection of the state and the behavior of the system as these applications run and have occasional failures, we'll be able to understand a little more about Elixir's supervisory model. So, at a base level, when Elixir starts an application, this list of children are all booted up and ensured that they're started. For them to boot up, they need to return an OKPID tuple. If all three of these don't return that OKPID tuple, the application as a whole will not start because its children can't get into a good state to ensure an integrity in the beginning. So if we raise foo here at the beginning with periodically, we'll see that the application never starts and none of those children ever get to boot. However, if we move this down, we put it inside of another and make that be the one that raises, we'll see something a little more interesting that shows how the behavior is sequential for the starting of these children. We can see here that if I save the file, one.periodically is started, but when we get to the second one, it blows up and the application never starts. Now, if we get rid of this raise and instead go to our occasional failure model with the inspection of state running, we'll be able to see something interesting. So as we begin, the state's 0, and we start to increment to 1, 2, 3, etc., and we hit 5 when we get our first failure. We see here that periodically is the one that failed, but because it's first in the list, the state of the other two is not affected. However, when we get to the third one, all of the ones before it are going to fail, which will happen when we get a bit above 20 here, and we'll see that everything ends up getting restarted to 0. So we've had this clean wipe, and now we know that the entirety of all of those children have had to be restarted because of that failure. Now, if we go in and we change our strategy to be 1 for 1, which is actually the default supervision strategy of Elixir, we'll see something more interesting. So, with this strategy, the individual children are only going to kill themselves and restart. We'll never have to deal with all of the other one's state being wiped. So as this increments, we'll see in a moment that the increments will continue for the other two after the failure hits 24, and likewise, when the one that fails every 5 will fail as well. So let's see here as it goes up. And now we can see that that one restarted to 0, and we had a restart for the other one that failed to 4, but now they're one off from each other because one didn't force the restart of another. There's also the one for all strategy, which means instead of having just the ones after it fail, everything will restart if we have any single failure. So here we'll see that every 5 we're going to have our state decremented down to 0 and begin counting again. And now it's began. So this was a pretty quick but useful examination of the supervisory behavior in Elixir. I started with rest for 1 because even though it's not the default, we had some problems with misunderstanding it recently at work, and I thought it might be useful to have a visual demonstration for more people to dive in and see how these work at a functional level with a quick glance. Thanks and happy hacking.